The key word for this week is specialization. And we're going to start slowly. So what I have up at the top here is a very basic version of the rectangle class. So scaled back almost 2 weeks to the most basic representation where we're storing the width and the height, and our constructor just takes the initial width and height. It doesn't even use the list of initializers like we're used to, like we know is probably a better practice. We're even avoiding the use of the const keyword, but we have our get width, get height, and get area functions. And then down here I have main, where I'm creating an object of type rectangle, giving it a width and a height, and I'm creating an object of type square. And I'll come back to the square class in a minute. At the moment, all I'm doing with the rectangle is printing it out. So I have a print operator defined for rectangles. It's this one. It prints out the word rectangle, I guess as a way to affirm that you actually did pass in a rectangle and got inside of the function defined on line 38 and ended up on line 39. And then it prints out the width, the height, and the area. So this is some way to print out rectangle objects. And we know that to run this operator, obviously, the compiler's only going to choose this operator if you attempt to push in something that actually is a rectangle. So where does that leave us in main? I'm going to begin by running the code as we have it. And it's not going to do anything very exciting because it just prints out the rectangle R and then does nothing else. So the goal that I want to accomplish in this video is to formally define, in terms of the language, the class square to be a specialization of rectangle. And although specialization, I think, is a good English word for what we're talking about this week, it isn't the term we tend to use in programming. We tend to use terms like subclass or inheritance in programming. And we're going to see over the course of the week, we introduce those terms more and more. I think this video is a good introduction to the concept of inheritance. Although it's a bit of an acquired taste at first, I think unlike a lot of the other features over the past couple of weeks that some of you could sort of take or leave, this is a feature that most people can catch on to pretty quickly. So once you get past the notation and the conceptual idea, I think it's pretty easy to become convinced that it really is helpful and actually sort of amazing that we can define things like this. So what I want is, I've got this object of type square. I would like to push it into my output stream just like I do a rectangle. And I don't mean that I want to define an operator to allow me to do that. I want to use the same one I use for rectangles, on the grounds that a square is a rectangle. And by the same token, I want to ask the square for its area, just like I might ask a rectangle. Now, a square has this added feature of, because all of the sides of a square are the same length, I suppose I could also, it's appropriate to ask, what's the side length of the square? It wouldn't make much sense to ask that for a rectangle because the sides of rectangles have different lengths. And then it turns out the square object provides change side length. So there's a way of changing the size of the square on demand, unlike the rectangle class, which doesn't provide that. So what's the square class look like? Well, it looks like this. So just like in the previous video, there are these sort of deliberate, glaring similarities between square and rectangle. For example, a square, rather incongruously, is stored with a width and height. It's sort of odd that I would do that, given that a square has all 4 sides the same length. And yet I have. It is, as we know, the decision of the square class how to implement its abstraction. So it chooses, because these are encapsulated, you've got no way on the outside of knowing that it's doing something so odd, but it is doing that. And then when you construct a square, again, I don't use the list of initializers, I just use assignment statements. When you construct a square, it sets its width and height to be the side length that you provide. When you change the side length, it sets the width and height to be the side length that you provide. And actually, I guess I could put in a plug for another option I have here. There is a function to change the side length, so if I wanted to in the constructor, I'm always allowed to call member functions in the constructor. I could just defer all of the construction over to change side length if I wanted to. I couldn't do the reverse. You can never construct an object a second time. But in a constructor, I'm welcome to call member functions that help me out. Now that's a bit of an aside. So I've got this square object that uses a width and height, almost sort of to really rub it in your face that it's definitely deep down a rectangle. And then it's got this get side length function. Now, I mean, both sides have the same, or all 4 sides have the same length, so we'll just say we'll return width, I guess. What I want to do here is I want to formally indicate that every square is a rectangle. And we do that by defining square to be, so I'm going to draw this diagram here. I have my rectangle class, and we'll notice over the course of the week, I like representing these relationships sort of like a family tree. So I've got my rectangle class, and we can think of it as the parent in the family tree of square. And the term I tend to use that you might notice me using in lectures is square is a child class of rectangle. Rectangle is a parent class of square. Other formal terms you might hear used, relative to square, we want rectangle to be the base class. And square, relative to rectangle, square is a derived class. We could also talk about rectangle being a superclass, so superclass, and square being a subclass of rectangle. I am a bit less fond of this terminology. I don't like the super and sub don't properly connote what I want here. And I like the term parent class and child class, but base class and derived class I think are the most formal terms you could use. The reason that I like to refer to it as parent and child is because one of the key words for this week is the word inheritance, which is a really big deal. And I think it's pretty difficult to come up with an example that demonstrates inheritance on its own in a way that's tangible. There are plenty of examples of classes with members A, B, C, and D or something, just ints, where we can show this off. I'm trying in this video to show it off in a way that seems a little bit more tangible. So I'm going to begin by defining square to be a derived class, a child class of rectangle. And so I write this. A class square is a rectangle. Now this access control specifier here is a bit unique to C++. Not many languages allow you the opportunity to decide if it's a public, private, or whatever rectangle. We're going to ignore what this means for now. In this course, all of the examples we actually need are going to have the word public here. The meaning of this is a bit obscure. I will try and talk about it in a later video for the sake of, I guess, tying up loose ends. But for now, line 44 is now saying this is a class called square, which is an extension of the class rectangle, a specialization of a rectangle. And moreover, this is making the firm statement that every square is a rectangle. So this means that every square has all of the attributes and members and member functions that a rectangle does, plus whatever you add to it down here. We call that inheritance. The square class inherits all of the attributes of rectangle, just like how a child inherits various like DNA from their parents. And so that's why I like that analogy, is that we can see the family traits in the square class that are inherited from the parent class. Now, C++ does allow multiple parent classes. You can define one class that inherits attributes from multiple other classes. In this course, we're not going to worry about that. And there are some languages like Java that essentially does not permit that. And for our purposes, we care about only single inheritance, although multiple inheritance is in fact a thing in C++, and it's a bit of a nightmare when you do have to worry about it. So what does it mean for square to inherit everything from rectangle? It means all of the members of rectangle now become members of square. And actually, I'm going to make a quick change here to prove a point that I'll come back to later in the video. Suppose we make all of the members of rectangle public, and I'll come back to when they should be public and when they should be private later. So what I've done here is defined a square to be a rectangle. Anything I can do with a rectangle, I can do with a square. And of course, not every rectangle is a square, but every square is a rectangle. And that means anything I can do with a rectangle, I can do with a square. I can ask a square for its width. I can ask a square for its height. I can ask a square for its area. And in fact, those functions now, because of line 44, already exist. And so I'm going to write that in. You wouldn't normally write a comment like this because it would be implicit, but just to make it clear. Inherited from rectangle. What if I inherited from rectangle? Get width. I've inherited get height. I've inherited get area. I've also inherited the data members. And so I actually no longer need my own members width and height. I've inherited the members width and height from the rectangle class. And we'll notice that, we'll go down to main and just make sure this is all uncommented. We will notice that we don't have to do very much work to make this code function. Now that I've defined formally that square is a subclass, square is a derived class, square is a child class of rectangle. So we'll try that. And it compiles. And if we take a moment to appreciate what's really going on there. So in main, I am pushing square into my output stream. And just recall and take, maybe you might want to scroll through the posted code while I talk about this. there's only one operator that can handle that handles printing in this piece of code, and that's this one. This operator resolutely expects that you give it a rectangle. There is no print operator for squares, and yet in main, I can throw my square object directly into the output stream because my square is a rectangle. Anytime you ask for a rectangle, I can provide you a square, and you can use it because the square has all of the functionality of a rectangle plus whatever else it decided to add. And we can see in main, I can also ask S for its area. And notice in the class square, there is no function getArea, but it gets that for free. It inherits it from rectangle. And so I'll run this. Okay, so the area, my square S has area, has side length 17. Maybe we'll change that to something a little bit more tangible. Suppose it has side length 6. Okay, so side length 6, the area of the square is 36. When I push it into my output stream on line 77, it prints out rectangle 6 by 6, area 36. And that's because my output operator prints rectangle. Just to make it absolutely clear, it thinks it has a rectangle, and it does. A square is a rectangle. And then on line 78, I print out the area of the square, 36, and then I print out the side length of the square. So get side length is something rectangles don't have, but squares do. The square inherited all the properties of rectangles and extended them. It added its own. And so it has get side length. I then change the side length, and I notice that when I print the square out again, now it's 10 by 10. Its area is 100 and the side length is 10. So I updated a property that was inherited from rectangle in the square class. Square has no data members of its own, but it inherits the members width and height from its parent class, from rectangle. It can now modify them just like any other members of the class. It can return the side length, which is width. It can control how the width and height are modified. So it can modify when you change the side length, it can modify width and height. If you ask for its width, if you ask for its width or its height or its area, well, it doesn't have those functions itself, but it inherits those functions from the rectangle class. And so we return height or width or area if we call those. And so the square class truly is a rectangle in every respect, plus a bit of extra functionality to represent the added personality of the square, the fact that its width and height must always be equal. Okay, so we've now defined this idea of inheritance, of defining formally one class to be a specialization of another. We can expand this to create the whole big family tree. I could have all sorts of different shapes, and I could define their relationships to each other, how some shapes are extensions of others. But before I do that, there's one last thing I want to talk about in this video, which is near the beginning, I suddenly changed line 32 to say public, and I said I'll come back to this. So now I'm doing that. As rectangle is currently written, all of its members are public. And all of them got inherited by the square class. But we should consider that I'm now allowed to define these extensions of my classes. But shouldn't the rectangle class get some say in that? So for example, shouldn't it be the case, because the rectangle class should have complete control over the rectangle type, shouldn't it get some agency over what subclasses can be defined, when they can be defined, and what they inherit, or how they can access what they inherit? And it turns out it does. So we look at this public thing and say, this doesn't look right. By this point in the course, if you see a class with non-trivial behavior, a class that isn't just a bucket of data, you should be a bit bothered by public data members. So we want to make this private. Let's see what happens if we do that. And we get a problem. And actually, I'm going to scroll and we'll show off where the compiler complains first. It actually complains on line 47. It says, I'm sorry, in the square class, you're trying to use width, but width is private. And when I make a member private, it turns out that the square class does still inherit a member called width, but the square class can't see it. Anything that's private in the parent class is actually part of the child class, but it's hidden from the child class. So the square class isn't allowed to modify the member width. It's something that is kept by the previous generation only. However, get width, get height, and get area are public in the parent class, and so they are fully inherited and are public in the child class. So what do we do here? I want some middle ground. I want the square class to still be able to use width and height, but I don't want to make them public. I don't want the general public being allowed to modify width. And public and private, the two access control specifiers we know so far, aren't sufficient for this. Private locks it down completely. When something is private, it can only be used inside of the class where it's defined, and by friends of that class. We saw last week we have the option of defining friends. And we'd rather not do that if we can avoid it. If something is public, anybody who has an instance of rectangle can access the member. We don't want that either. We don't want to completely compromise our access control and our encapsulation. I want a middle ground. I want a way of defining members that can be inherited and that can be modified by child classes, but I want to keep it in the family. And there is a middle ground. It is the access control specifier protected. If a member is listed as protected, it is accessible fully by the class it's defined in and all subclasses of that all the way down. So for example, if I were to later define a subclass of square called, I don't know, unit square, that would be a square that's always 1 by 1. Unit square is a square, and a square is a rectangle. So a unit square is a rectangle as well. And that means a unit square has an area and a width and a height, and a unit square would have the members' width and height. And because they are protected in rectangle, they are available to everybody below rectangle in the hierarchy, as if they are regular members of the class. So it does allow inheritance, and it does allow the child classes to access the member, but everybody else cannot. So a protected member is private to the outside world, but available, and you could think of it sort of as public inside of the family. So I'll just run that to prove that the protected keyword does help us there. And we can see I changed it from private to protected, and now the code compiles and runs again. So what we're going to unpack over the next few videos is the real implications of inheritance. So what does it really mean to get all of the members and data from the parent class as part of every instance of the child class? But also, what happens if the child class wants to improve upon or refine or extend the behavior of the parent class? For example, what if it were the case that computing the area of a square required a little bit different of a calculation from the area of the rectangle? Wouldn't it be nice if I had some way of maybe overriding the way that something is done in the parent class when I define the child class?